Aloha and welcome to this introductory screencast on ICS 314, Software Engineering 1 for Fall 2018. My name is Philip Johnson. I will be the instructor for sections 1 and 2 of this class. Cam Moore is going to be doing section 3. Here's some contact information for myself and for Danny. Cam will give you his contact information separately, and I'm not sure who the TA for his section will be. But you should know that the website is the same for all 3 sections, and the Slack workspace is the same for all 3 sections, and the homeworks and so forth will pretty much be the same for all 3 sections. Some of the quizzes actually will be different from between the different sections. We try to not duplicate the quizzes. My office is post 307A. Cam's is post 307B, so we're together, and find post 307, you'll probably find one of the other of us. My office hours are Tuesday, Thursdays after the section 2 class is over, or you can come by my office, and Cam's pretty much the same way. You know, if my door's open, wander by. Usually we can talk to you. If we can't, we'll let you know, but it's pretty informal. What we're trying to do here is help you learn how to build high quality and reasonably large scale software systems. So far you might have been building, code, I don't know, 500 lines of code, 1,000 lines of code. What we hope after this class is over is that you'll have the skills necessary to build 200,000 line of code systems, or maybe up to 500,000 lines of code. The techniques for quality assurance, for project management, for using a version control system like Git effectively, all that stuff is going to enable you to basically kind of go up a couple orders of magnitude with respect to the scale of software you can build. Now, when you get into systems that are maybe 5 million lines of code, that starts to be a kind of a different ballpark, and I'm not going to claim that in one semester I can really get you the point of understanding how to do software that's that big, okay? But there is a sweet spot, around the several 100,000 lines of code where, you can build some pretty decent things in 300,000 or 400,000 lines of code. So, while you're not going to learn everything you need to know about software engineering, you're going to have a decent basis. The other thing that's going to happen in this class is I want you to start working on your professional persona, and by that I mean a professional portfolio, as well as participation in professional online social networks like TechHui and LinkedIn, and the creation of technical essays that help establish to future employers and graduate schools and so forth kind of what your skills and interests and capabilities are. And so we'll be working on that. Let me pause this. And I also finally want to help create a mechanism that you can learn complex material fairly efficiently. And to do that, we use this thing called athletic software engineering. And I've been working on this approach for a few years now. And generally speaking, between 90 and 95% of the students in the class prefer this approach by the end of the semester over a kind of a traditional classroom structure. So not everybody likes it, but almost everybody likes it. And I think, as time goes on, you'll start to have some fun with it. So for this class, you need to have some programming background. I don't need a lot, but I need some. So you should be, kind of through your second semester of programming. Development environment, you need a laptop. You need to come to class with a laptop every single session, because we'll be doing a lot of work in class. Really, any operating system, Unix, Mac, or Linux is fine. Windows is the worst, by a significant margin, but you can get by on like a Windows 10 environment. You can't use the ICS lab. If you need Windows 10 and you don't have it installed, we can get you a free license. Finally, you need to really devote a fair amount of time to this class. I'm not going to lie, it's very time consuming. That's just the nature of the beast. It's not that I'm kind of a horrible, person that is assigning you needless work just to kind of use up your life. The fact of the matter is that software development is just really hard. It just takes a long time to understand, work through the bugs, and get comfortable with the technology stack. And just for everybody, it just takes a long time, myself included. I mean, I spend countless hours, trying to build things. And so that's just the way this field is. And I'm sorry. I wish that you could spend 2 hours a week and learn all this stuff, but it's really going to be more like you're going to spend 10 hours a week, and we'll talk more about that in class, about the time requirements. You need a laptop for the class because we'll be doing so much stuff in class, and a decent modern laptop, a couple years old, should be fine. You don't have to spend a mint on the kind of the latest high-powered laptop, but you do need one that has these kinds of requirements. Grading, this is a real general kind of thing. About 50% is going to end up on your technical essays and your programming assignments, quizzes, which we call WODs, workouts of the day, and the final might be the other half of it, but that could be wildly different. I'm not committing to that, but I'm just telling you kind of how things will be breaking up. What I will commit to at this point is that if you have 90% of all the points that are available by the end of the semester, you're going to definitely get an A. Okay, if you have 80%, you're definitely going to get a B, and 70% you'll definitely get a C. And I also, depending on how things go, sometimes I grade hard, or assignment turns out to be much more difficult. So it may be the case that at the end of the semester, 88% will be enough for an A. I don't know yet. But 90% for sure. I'm going to give everybody an A who gets 90%. So it may be the case that every single person in the class gets an A. Okay, that's not bad. I don't mind seeing that happen. It just means that all of you learn the material. So you're not competing with each other in the class. There's no curve or anything like that. So the class kind of has two parts. The first part is this thing called athletic software engineering, where we have a set of modules. Each module focuses on a skill. The goal is for you to be able to solve problems using that skill quickly. And in order to assess that, each week on Thursday, we're going to give you this assignment. There'll be a certain number of minutes you'll have to solve the problem. If you don't solve it in that time, you get a DNF. You don't get credit for that assignment. And the idea there is that if you do all the homework assignments and practice them until you can solve them in the time required for those assignments, then you should be fine to solve the problem in class. Okay, that's the way it works. And really pretty much every semester, the first couple of weeks, people are still kind of getting used to it, and then you kind of get in the groove, and almost all of the students will focus in, do the homework, keep up with the class, and then they'll do fine on this. It's also the case that learning how to write about technical topics clearly and concisely is very important, and so we're going to give you some practice in that. The first two sections of the class are writing intensive, so you get that that little check mark next to, or you'll fulfill that requirement by taking sections 1 and 2. As I said before, I want you to start to develop a professional persona as part of this class. That means your technical essays, your professional portfolio, very importantly, the open source code that you authored, so that people can later go in and look at your GitHub repository and see code that you developed. I believe that the professional persona is a career-long project. I'm still working on mine, and the level of quality that you're able to exhibit through your professional persona is going to really help or hinder your future job and graduate school opportunities. So this is a chance to get started and to start actively thinking about it. Finally, collaboration versus cheating. It's pretty straightforward in this class anyway. I want you to collaborate. I want you to talk with each other. If you're having a bug while you're doing development, I want you to be able to feel free to ask someone else to help you understand what the bug is and figure out how to solve it. All that is fine. The definition of cheating is taking somebody else's code and submitting it with the assumption that I should think it's yours. Okay, so if you submit somebody else's code, it needs to be clearly attributed to as somebody else's code. Okay. Another form of cheating is providing information about the 9 a.m. WADs to the 10:30 a.m. class or the noon class. But other than that, which I think is a fairly straightforward, definition, feel free to talk with each other about everything. If you ever have a question about whether something is appropriate to share with somebody else, then just come talk with me about it, and we'll figure it out. Okay? Reason: cheating, destroys the academic environment. Okay, people lose motivation when they feel like some people are going to get a good grade just by cheating. Okay, so it's not a curve. Everybody can get a good grade. So everybody just please follow the rules, don't cheat, and get a good grade. Okay, it's certainly possible for everybody to do it. Finally, I want to say that I think software engineering and high technology is an important aspect of the future of Hawaii, and that I really want you to enjoy this class. I really want you to enjoy software engineering, software development, because I think that there's a critical shortage of people with these skills in Hawaii, and I want you to have a great job here in Hawaii and stay in Hawaii and help this beautiful place get better and better. Aloha.